If you're new to Godot or just game development in general, you might be a little confused as to what exactly scripts are in Godot. Now, I've been playing around with Godot for a little bit now, and I've become a little bit used now to how scripts are written, and it's not something completely new to me as I was very familiar with C++ in Unreal Engine for writing classes, and I was very used to writing components in Unity using C#. I think that's what they were called. It's been a long time since I've used Unity, but I've now gotten used to how they work in Godot, and so in this video I want to break down exactly what scripts are, how we use them, and what exactly is their purpose. Now, this is going to be the first in a series of videos that I make on just simple breakdowns on what you can do in Godot, so if you guys want to see even more like this, let me know what other parts of Godot you'd like me to break down in the future. With that, let's go and jump right in the next reality. Let's maybe start with the most basic question to answer first. What exactly is a script? Now, in its most basic form, a script is just a set of instructions that allow for us to add in some sort of functionality into our game or whatever other project that you happen to be creating. And because of Godot's very modular nature, you can very easily make as many different scripts as you would like that all are specifically designed for different functionality. For example, you could have one script that is specifically designed just for moving around an environment. You could have a second one that is designed for interacting with buttons and levers, a third one that is designed for spawning in portals, or you could even have a fourth one that is specifically for picking up boxes and other kinds of things that you might have in your environment. Now, you don't necessarily have to split up all these different scripts into different scripts. You could just combine these all into one and create multiple different scripts that are all designed for different players, maybe different AI, maybe different sorts of functionality within the environment. But because of the way that Godot is designed, you can split this up as well into as many different parts as you would like, and this allows for you to reuse that same functionality over and over and over again. The other thing I'm going to note as well, and you might notice this when you go to actually download and install Godot, is that there's actually two different versions. You have your .NET version, and then you have your GDScript version. Now, the difference between these is actually pretty minimal, but it's pretty big in terms of scripts and what you're allowed to do with them. Now, the .NET version allows for you to write scripts using C#. And I should note that I use scripts only because that's what Godot calls them. C# is actually not technically a scripting language. However, that being said, C# is a much more standard and commonly used programming language in a lot of other engines as well, such as Unity, for example. And while .NET does technically work, it's not technically the preferred way that you're going to probably end up using it in Godot. Now, GDScript, by comparison, is a scripting language that is specifically designed for Godot. And because of this, it actually works a little bit better with Godot, especially if you're newer to Godot and programming in general. Now, you can technically speaking use either of these if you're comfortable with C# or you're comfortable with just that programming language, or stepping a little further and learning something that's a little more standard. You can certainly go in and start learning how to use C# and using that in your Godot project. And there's lots of other plugins that allow for you to add in other programming languages as well. That being said, I myself, and as you might see in a lot of other tutorials and guides that you might find online, you're probably going to end up seeing that most people are going to end up using the GDScript language, not simply because one is better than the other, but specifically because that's specifically designed for Godot and it just tends to work a little bit better with Godot. So with that, now let's go and jump into the editor and I'll show you very simply how it is a script works and how it is we go about writing one. Alright, so we've talked about what a script is. Now let's go ahead and talk about how do we create a script, what are some of the basics to writing a script. So first off, let's talk about how we create a script. There's three different ways you can do it. You can come down here to the file system, right click, create new, and create a scene. You can also do that in any subfolder, of course, but that's going to be one of your ways to create a script. You can also right click on any node that you have within the scene, and then click attach script. Now, scripts can be attached to any node. There are some limitations and some possible errors that you can run into when you do that, and I'll talk about that in a minute. And then the final way is you can, again, click on whatever node you want to attach a script to, and then click this icon right up here. and that'll allow for you to attach a script as well. So once we go to create a script, we're going to end up with this window right here. So this window has a few different things here. First off, we have language. By default, this is going to be GDScript. If you have the .NET version, it'll give you C# as an option. Like I said, I'm not going to be using C#, but that is an option there. Then you're going to have inherits. So if you actually have a specific node that you're trying to attach a script to, and you either right-clicked an attach script or you hit this icon while clicking or while having a node selected, it's automatically going to fill that inherits with the type of node that you currently have selected. You can also change that. If you hit this icon right here, you can then click whatever node that you would like. And there is some significance there. Again, I'll go into that in a minute. Then you have template. Most nodes that I've come across don't seem to have any default templates. Character Body 3D does have one for basic movement, since it is designed for being used with the player and also AI NPCs. So there is a default Character Body 3D template you can use that will just kind of set up some of that basic movement. And then you also have built-in script and just a simple location for wherever you want your script to be placed in the file system. I have found that the best way for me to manage that is to have a scripts folder. I'm not going to do that for this video. This is going to be a very simple project, so I'm just going to leave it as part of the root of our file system. I am going to change this though. We're going to go and call this script 0. Okay, keep it nice and simple. All right, and then we're going to go ahead and click create. All right, so let's go and break down the script that we actually start with. So first thing we're going to notice is we're going to have this extend mesh instance 3D, and this is actually very important. So when we actually have this extends mesh instance 3D, you might recall this is what we're inheriting from. Now this script is going to expect that we only attach this script to either a mesh instance 3D or a soft body 3D. Now, how do we actually figure that out? If we were to go up here and we were to create a node, for example, we would find, I'm just gonna close down some of these. If we were to look for a mesh instance 3D, it would be under node, then under node 3D, visual instance 3D, geometry instance 3D, and then we would have our mesh instance 3D. And if we were to take a step below that, we'd have our soft body 3D. Now, whatever we're extending from should either be, we should either be attaching this script to a node of that type or to something below it in this hierarchy. It won't allow for us to, for example, attach it to a CPU particles 3D, a node 3D, or something else like that. And we can actually see, if I close out of this, if we were to attach our script 0 right now to the world, we would actually see, because our world is a node 3D, that when we start this up, we're actually going to get an issue because it's going to say script inherits from native type mesh instance 3D, so it can't be assigned to an object of node 3D. Now, if we wanted to change this later on down the line, we could actually just change this line to be a node 3D. And because the mesh instance 3D we have here is actually a type of node 3D, just a couple layers down in the hierarchy, we can actually restart it and we'll see that it's still going to work just fine. It's only going to cause an issue when we attach it to something that's not a mesh instance 3D or something below that in the hierarchy. I'm going to go ahead and revert that back. It really doesn't matter what we're using in this case, but just to put it back to where we were at. Perfect. Next thing you're going to see is we're going to have a couple functions. First one is going to be our ready function. Ready function runs either when the level starts or when this object or this script gets spawned into the world, whichever of those happens first. So for example, if we were to spawn an AI into the world and we attach this to the AI's mesh, this would run when that AI gets spawned into the world. Same thing if we were to just start up the world right now, this would actually run when the world starts up. Now, I personally don't find that there's a ton of things I need to do when we start up the world. There's usually little things like I have run into issues where setting variables at start can cause issues. If you need to set a variable at start and you need to access something within the world, sometimes it works a little better when you run it through the ready function. There is an alternative to that I did recently find that should work about the same, and I'll talk about that in a minute. Yeah, ready is basically this runs right off the bat, right when we spawn in this script. Then we have process. Now I'm actually going to put this into two parts. I'm going to add in something else here. We are also going to have physics process. Now these almost do the same thing. Physics process actually runs with the physics engine. It's a set amount of time between how often we run this physics process. Now, I could be wrong, but I believe by default, Godot runs the physics process 60 times a second. That is consistent. It does not change. It will consistently run at 60 times a second. The delta value that you do also see here is how long it's been since the last time this process has run. Typically, that's going to be in like fractions of a second, but that's what the delta value is going to be. Process, on the other hand, is actually going to run every frame. So process can actually sometimes be less reliable depending on what it is that you're doing. If you're running a game at 60 frames per second, then guess what? This is going to run 60 times a second. However, if something happens to your game and all of a sudden you're running down at 20 frames per second, whether it's because of something that you put into the game or it's simply because of the hardware that this game is currently being run on, this process is now going to be run at 20 times a second. And so on and so forth. It basically runs every frame. It's not quite as consistent. Now, the reason I put both of these side by side is because you might see these both used and it might seem somewhat like they're being used interchangeably. And maybe to some people they are, because they do kind of perform the same thing. It's a consistent thing that happens that you can always depend is going to happen within your game. But they both do technically serve a slightly different purpose. And I should also note too, physics process, I could be wrong, but I believe in project settings you can actually change how often physics process runs. So if you need to run it more or less every second, then you can change that. But that's generally how those two are going to function. Now let's talk about a few basic things that you're going to want to know as well for your scripts, aside from these default functions. And there's two things that I think are pretty important to know when you're creating a script. The first one is variables. So creating a variable is pretty simple, and you can actually go quite in depth when creating a variable. So creating a variable, we can do test_var. And what this does is it just assigns a variable, and this is some sort of stored value or stored reference. And this is the name of our variable. Now, this variable, you can name it whatever you'd like. You're going to see in a lot of Godot documentation and probably a lot of different tutorials that most variables do tend to follow this snake case when people write them. You don't have to. There's no, strict standard. You don't have to do things a specific way. I could write it like this, just have like something long or whatever, add in a number there or something like that. But the typical standard that seems to kind of go along with Godot is this snake case. Now, there's a little more to this. If you're familiar with programming, you might notice that we're not assigning this variable with any specific value. It's not a specific type. By default, Godot will allow for you to set a variable to any type. It could be a Boolean, it could be an integer, a float. You could reference it as another object within the scene, whatever the case may be. There's a couple ways that we can actually set this variable. So first off, we could specify the type. So for example, we could do a node 3D, and that's going to be any node 3D object. We could set it to an int. I don't know why I capitalized int there. We could set it to an int. We could set it to a bool. And if you don't know what these are, I would suggest just having a quick look at what these different types of storage types are. But this allows for you to basically set this variable as a specific type, and you won't be allowed to change that later on down the line. Now, if we go back to a node 3D, let's say we wanted to set this to node 3D. What we could do is we could then add an equals, and we could take something like our world and drop that in as our node 3D. You will notice, however, that we do end up with an error. And this is because by default, we can't actually set specific things within the world or within the scene this way in a variable. In order to set this, we actually have to then add onReady like that at the beginning of the variable. And this is basically going to say, hey, we're going to set this variable, but it's going to happen once we actually launch the game. We're not setting it right this moment because we're not actually able to set it in this moment. So make sure that you're using that onReady if you're doing something like that. Now, again, going back to this, we could also set it to something like an int, and then we could set it to, say, for example, 5. That would work just fine as well. Now, if we want, there's actually another way we could do this same format of things. We could actually just take out that int and set our variable like that. And what this does is it tells the script that test var is not only going to be equal to 5, but we're going to enforce that this is an int. So we can also modify that as well. If I were to do 5.0, now it's a float. If we were to set this to true, now it's a Boolean. And there's a lot of other ways, you know, obviously any other data type that you could set that to. One last thing that I'm going to talk about with variables. What if we want to set it to something at random? We don't know yet what we're going to set this to. You know, maybe we want to create a gun. We're going to have a lot of different types of bullets that we can spawn in. We want to make sure that we want to set the correct type set the correct bullet that we want to spawn. How would we go about doing that? What we would end up doing is we would do a couple things. Let's do an @export var test var, and then we actually do in this instance need to set what this type of variable is. So if we were to go back to our node 3D example, what this will do is if I click on our mesh instance 3D, you'll see over here in the inspector, we now have test var as something that we can access within the inspector. So we can now, I think I just called it expector in the inspector. So we can now click on assign, and it's going to give us the option of any node 3D in the world. And you'll notice too, it'll only allow for us to set valid nodes in this instance. It won't allow for us to set something like the node as this test var because node is not a type of node 3D, but a node 3D is a type of node. So you'll notice that node is nowhere to be seen in here. You can click that show all and it's just gonna gray it out. It won't actually let you select it, but that is something you can see there. And that's gonna allow for you to set that variable dynamically based on wherever you're using this script currently. And again, we can change this to an int, for example, and now it's a value. We can set it to 5 or whatever the case may be. Last thing that I think is pretty important to have here in this video is signals. So signals, we create very simply. I'm just gonna call this test signal. I don't know if this is the technically correct naming structure for signals. I need to double check that. But I'm going to use this naming for this anyways, this snake case naming. So a signal is quite simply, we come over here into node, and you're going to see we have a script0.gd section now, and we have a signal. So what this allows for us to do is basically double click on this, and we can attach this to any script that we have within our scene. So for example, if we wanted to attach it to the same script for whatever reason, we could hit connect, and it's going to create a signal that we can use here. So for example, we could do print, hey, this is in the signal. And then what we could do is do test signal.emit. And this emit, what it'll do is it'll run this signal, and any functions that we have attached to the signal will run all at the same time. And we can connect multiple functions all at the same time as well. So if I were to go ahead and hit play again, you'll see down here we get, hey, this is in the signal. Now, if we want to pass through a value along with the signal, we could actually add in some brackets here, or some parentheses, and then we could do something like test, actually I'll call it test param. Then once we have this parameter set, we can optionally also give this a type. We don't have to give this a type. We can technically just say, hey, we're passing through some variable. I don't like to do that typically. And then the only problem with doing it this way is then you also have to go through and you have to make sure your functions also have that as a parameter as well. Or when you go to make this connection, it will automatically create that function with the parameter there. So now I can go through and I can pass through just test param. And then we can now pass through a string along with our emit. So I could say, hey, we are emitting. And what we'll see now is because we're passing through this parameter, it's basically going to come through as our test param, which is then going to come down to the function when we emit. So if I go ahead and hit play, you'll see, hey, we are emitting. And this basically allows for us to create a signal where we can have different parameters. Maybe we want to run different things on these functions depending on what parameters we are passing through. And that just kind of keeps things nice and simple that way. And it allows for us to reuse this function this script with different functions. So for example, if we have something that's like elemental effects, we could have that elemental effect do different things depending on like the AI enemy, or if it's the player, or anything else like that for that matter. And that's a very simple breakdown of what scripts are in Godot. I hope you guys enjoyed this video. Let me know down below what other kinds of breakdowns you'd like me to do on Godot. And with that, I'll see you in the next reality.